In Chapter 4, Section 2, we're going to talk about standard form of a quadratic function. Now, yesterday we talked about vertex form. We learned how to graph using vertex form and how to actually write vertex form given a vertex and another point. And that was y equals a times x minus h quantity squared plus k, where h and k were the vertex. Today we're going to talk about this form called standard form. That is y equals ax squared plus bx plus c. They're both the exact same graph. They're both going to look like parabolas, but the different forms can be helpful for different scenarios. In order to get from yesterday, so which was vertex, in order to get from vertex and into standard, you just multiply the equation through and combine your like terms. I thought it would be best if I showed you an example. Let's say from yesterday that you had y equals 2 times the quantity x minus 3 squared minus 4. Now this is in vertex form, and if I asked you to find the vertex, I'm hoping that you would tell me it's a positive 3 and a negative 4. And then you would graph accordingly. If I wanted this in standard form, which we'd use for different things, we would go ahead and multiply it out. So we would get y equals 2 times x minus 3. Now write x minus 3 twice since it was squared. See how I wrote 2 times x minus 3 minus 4. You're going to multiply these two binomials together. So I'll get y equals 2 times x squared minus 3x plus 9. Now that's called foiling. Not that foiling's a real word, but that is called foiling. And combine your like terms here. Notice I didn't forget the minus 4 at the back. Y equals 2 times x squared minus 6x plus 9 minus 4. I put together the two minus 3x's. Minus 3x and minus 3x to make a minus 6x. Distribute your 2. 2x squared minus 12x plus 18. Don't forget about the minus 4. And last step, just put the 18 and the minus 4 together. Y equals 2x squared minus 12x plus 14. This form's a lot easier to work with if we're plugging in numbers. This form's a lot easier to work with if we're graphing.